Today, we are going to discover how Wagners CFT is designing infrastructure for faster and cheaper construction phases and how to translate those designs into a better bottom line for your business. Good morning and welcome to our webinar, The Right Connection, Construction, Part 2. I'm Georgia Lance, Marketing Officer at Wagners CFT, and I'm here with today's guest speakers, Wagners CFT Business Development Manager Robbie Westley and Site Manager Ben Brooks-Veivers. Robbie is a Business Development Manager at Wagners CFT. With more than 15 years working with Wagners fibre-reinforced polymer products, Robbie brings deep industry knowledge and a strong track record in delivering innovative FRP solutions across diverse infrastructure sectors. He works closely with clients, engineers, and project teams to drive adoption of durable, lightweight, and sustainable composite technologies. Robbie is passionate about helping organisations improve asset performance and longevity through smart material choices, and he plays a key role in expanding the reach of FRP solutions across Australia's most demanding environments. Ben is site manager and a qualified carpenter for Wagners CFT, where he leads the delivery of fibre-reinforced polymer solutions across a range of infrastructure projects. He is responsible for overseeing site execution, coordinating production and installation activities, and ensuring projects are delivered safely, efficiently, and to the highest quality standards. With strong hands-on experience in construction and composite manufacturing environments, Ben brings practical leadership and a calm, solutions-focused approach to complex site challenges. He works closely with engineering, fabrication, and project teams to ensure seamless delivery from planning through to completion. We're also joined by Wagners CFT General Manager, Australia-New Zealand, Ryan Leeson, who will be facilitating the Q&A session at the end of the webinar. Welcome, Robbie, Ben, and Ryan. Before we get started, just a few webinar protocols. We are recording today's event and we'll make the recording public via the Wagners CFT YouTube channel. You can ask a question anytime during the webinar via the chat bubble at the top of the screen. However, we will hold your questions over to the end of the webinar for the Q&A session. And for anyone having difficulties accessing the chat facility, feel free to text me your questions on the mobile number that I have just popped in the chat now. So let's dive into today's webinar. I will hand over to Robbie.
All right, thanks, Georgia, for that. Welcome to the Right Connection Part 2 webinar. So over the past 30 years, Wagners have delivered over 2,000 structures for various applications ranging from boardwalks, bridges, jetties, wharfs, staircases, and many other applications. Over that time, our designs and methods have evolved to increase efficiency in both design and installation. In today's webinar, we aim to show several of these evolutions and also give some practical examples of how different connections go together and how to more efficiently install them to save time on site and reduce installation costs to the client. So what we're going to discuss today, we're going to talk about installation contractors' feedback, their fears, pain points, and assumptions, and how Wagners have taken this on board and made design changes to increase installation and efficiency and save costs. Connection types and working examples of how to construct and estimate, anti-crush blocks and crush tubes, time-saving tricks of the trade, showing how to most efficiently install different connections, case studies and multiple projects where simplified connections have produced better value installation outcomes, piles and pile connections, circular and square, and also Wagners available resources. Speaking contractor feedback, Speaking with our contractors over the years, there have been several recurring themes and feedback received in relation to pain points, bottlenecks, and perceived additional time and labour required on site. I'll now hand you over to Ben Brooks. Oh, hang on a second, sorry. So some of the feedback has been anti-crush blocks are hard and time-consuming to insert. Too many bolted connections. What other options are there? What if I need to drill a hole non-centered? Additional time spent cutting and drilling. How can we connect to or use open sections? And what prefabrication options are there? I'll now hand you over to Ben Brooks-Veivers to address these feedback points, as well as give you some more in-depth information on connections, crush blocks and tubes, some case studies and comparisons, and general time and cost-saving ideas.
Thanks, Robbie and Georgia, and good morning, everyone else. So crush blocks were once the only option for a bolted connection, and this left little to no room for error on site. Designs had to be perfect, and every step of the installation on site also had to be perfect. There was nothing worse than starting construction and finding a pre-drilled and inserted member missing a crush block in the center. A lot of the time, these mistakes would result in the member needing to be replaced or remade on site, which ultimately was difficult as the stock crush block is made to be tight for when we detail a glued connection, meaning inserting on site is very difficult. Prior to the designs being altered, there were several on-site techniques used to overcome some of the previously mentioned problems. Although sanding down crush blocks is one of the easiest techniques used to make inserting them easier, it is crucial there is still friction there, because if too much is sanded off, the connection capacity of the crush block is reduced. The same occurs when the hole diameter is increased as the webs in the crush block become damaged. The solutions on the slide all make install smoother, but also all have minor downfalls relating back to the connection capacities. Here we take a look at some typical connection details showing standard designs for bush connections, inserted connections, and riveted connections. These are some typical connection details showing standard designs for square piles, round piles, and you'll notice the far less shaded sections on the right-hand drawings, as round piles can only have a bush connection. Here we'll take a look at our first case study. So bicentennial project, components and design consisted of square posts, crush block bearers, crush block posts, tie brace for handrail post connections, and part crush blocked and bush tubes for handrail posts. As you can see, the rough time breakdown to install a bearer to a two-post connection. There, the process to achieve a finished connection takes a total of 26 minutes, and at $100 per hour for labour and the project's total of 120 bearers, you end up having a rough cost of $5,200. But other project components and design consisted of round 178 piles, crush block bearers, bushed piles, riveted diaphragms, and bush joists for handrail posts. As you can see, the rough time breakdown to install a bearer to pile connection there. The process to achieve a finished connection takes a total of 22 minutes, and at the same $100 per hour for labour, with the project's total of 240 bearers, you end up having a rough cost of $8,800. At twice the quantity of bearers to bicentennial, you can see the bush connection is far more efficient and cost effective. Jump into crush tubes now. So the increased use of crush tubes across our designs means that an alternative connection solution is now available for most applications, helping to minimize delays and improve flexibility during construction. As highlighted on the slide, crush tubes offer several advantages that not only simplify installation on site, but also reduce the likelihood of errors, rework, and associated costs. The bush connection's versatility ensures that connection capacity is less susceptible to reduction when real-world conditions deviate from the design intent. Crush tubes are now being used extensively across projects, as reflected by the reduced number of crush blocks appearing in hardware packs and design details. While crush tubes offer several advantages, there are still some important considerations to be aware of, as highlighted on this slide. When drilling FRP members for bush connections, the hole size must be selected to suit the outside diameter, the OD, of the bush rather than the bolt diameter. For example, an M16 connection that would typically require an 18mm hole when using a crush block will instead require a 22mm hole to accommodate the bush. Another critical requirement is ensuring that the overall length of the bush is 1 to 2mm shorter than the overall width of the member. For instance, a 125 by 125 FRP member would require a bush with a maximum length of 123 or 124mm to ensure proper installation and performance. Jump into riveted connections. So riveted connections are simple, efficient, and easy to install. While they may not always provide sufficient capacity for heavily loaded structures, they are often the preferred connection solution for when higher load requirements are not a factor. As shown by the advantages listed on the slide, riveted connections offer several practical benefits. Installation does not require a trade qualification or specialised training, nor is there a need for custom drill jigs or drill shafts. In addition, if installation errors do occur, they are generally easier to rectify and are less likely to cause significant damage to the FRP members, reducing both rework time and repair costs. So we'll take a look back at Baribadala in a bit of a hypothetical case. The Baribadala joists were designed to use a riveted bracket connection to the bearer. To highlight the benefits of this approach, let's compare the installation process with a hypothetical bolted connection. This slide outlines the additional steps that would be required if the outer joists, which carry the handrail post loads, needed increased connection capacity and therefore had to be bolted instead of riveted. Even from a simple comparison of the installation steps, the riveted connection is significantly more straightforward, while the bolted connection requires a greater degree of planning and coordination. If this planning is overlooked, installers can encounter the same challenges previously discussed with crush block connections, as can be seen by the rough install times shown. There is a significant time and cost saving benefit to the riveted connection. The ability to prefabricate and transport complete or partial assembled bridges or boardwalk components is one of the most effective ways to reduce installation time on site. Even when site access limits the transport of large assemblies, there are often alternative prefabrication options that can be developed in collaboration with the production team here. Prefabrication is not limited to assembling and tying a bridge or boardwalk section. It can also involve completing smaller tasks in the factory, such as installing components in advance to reduce the number of rivets that need to be installed on site. While prefabrication can deliver significant efficiencies, there are situations where the options shown on this slide are not practical. For example, driven piles cannot typically be installed with the level of accuracy required to reliably achieve our 2mm tolerance, meaning some connections must still be completed on site. Our Phil Hill project components and design consisted of round 178 piles, crush blocked bearers, riveted diaphragms, and bushed handrail joists for 4 handrail post connections. In this example, we will focus on the riveted diaphragm connection and demonstrate how collaboration with the production team can generate significant site efficiencies. By completing 50% of the required rivets in the brackets in the factory prior to delivery, a substantial amount of on-site labour can be eliminated. Each 250 by 100 diaphragm contains 8 riveted brackets, requiring a total of 48 rivets per member. Across the project, this equates to 21,120 rivets for diaphragms alone. On the Baribadala project, all 21,120 of those rivets were installed on site. This effectively required a worker to spend almost 2 weeks in the same location solely riveting brackets to the diaphragms. For our Phil Hill project, however, the production team pre-riveted half of the bracket connections before the components arrived on site. As a result, the number of rivets requiring installation during construction was reduced to 10,560, delivering an estimated 6-day reduction in on-site construction time, while also improving productivity and reducing labour demands. Here you'll see our open sections. So we're now starting to see designs for our C-channel members, which are shown by what is on the slide. You'll notice on the details there are no crush blocks shown, just crush tube in the piles. The Christabrook boardwalk is a low-level structure that utilizes C-channel joists and bearer connections with round piles. Where higher load capacities are not required, this type of connection can be a highly effective and efficient solution. As outlined on this slide, C-channel connections offer a range of benefits. One of the key benefits of these members is their lightweight construction, which helps many projects. Many projects are also carried out in challenging or remote locations, and reducing the weight of the materials can significantly improve site efficiency. Lighter components are easier to handle and install, reducing the physical strain on workers and lowering the risk of manual handling injuries. They also minimize the reliance on heavy lifting equipment and machinery required, which reduce costs, simplifies logistics, and improves access in difficult site conditions. Here I'll take a look at round piles versus square piles. So square piles were once the standard pile design used across all of our projects. Today, however, round piles have become the preferred option in almost all applications due to the significant practical advantages they provide during installation. One of the key benefits of the round pile is the increased installation tolerance they offer. Achieving perfect alignment between two 125 by 125 square piles is particularly hard in hard ground conditions. This was often extremely difficult and time-consuming. When this alignment could not be achieved, the consequences frequently involved additional site work, such as manufacturing and installing custom-shaped packers between the bearer and the pile to maintain a consistent connection interface. By adopting round piles, these alignment challenges are largely eliminated, resulting in a simpler installation process. As you'll see on this slide, driven piles are not the only option available, as you can see. Everything I've spoke about today requires the use of tooling, some custom and some available from your local tool shops. If you'd like to know more about these items, you can watch our previous webinar, Tricks of the Trade, which will detail each of these items. And back to Robbie now.
Yeah, thanks for that. Ben, that was very informative. So just to finish up on our last couple of slides, what these case studies prove is that with the right connections, time on site is significantly reduced. With the less time installing, there will be a lower cost. And with a lower cost, that leads to more competitive tender pricing. Our final takeaways before we move into our Q&A. What we think we've given you today is a better understanding of how we build up costs to greater assist contractors and estimators in pricing up work. We've demonstrated that all connection types have their place. It's not one solution for all problems, and there are a lot of innovative ways to do that. There is a measurable cost and time saving through innovative design, and the adaptability of different types of connections will always have ongoing cost saving effects as long as you make the selection early in the piece so it can be planned for. And last but not least, we're here to help. Wagners have a large number of highly skilled engineers, draftees, estimators, project managers across the board. So if you're looking at a project and pricing it up and you're trying to work out how you're going to price it up, what's the best way to build up our price, and you want some assistance with that, just reach out to us. We will get the right person onto the job to assist you and allow you to put your most competitive tender submission in. In regards to available resources, I would highly suggest going to our website where we have the Wagners installation guide, a drafting guide, and a design guide, as well as a number of other useful resources. Prior webinars, tricks of the trade, piling with Wagners, and the right connections are all available at our website in the webinars section. So after that, I'll pass back to Georgia to facilitate the questions section.
Thank you very much for your presentation, Robbie and Ben. We're about to dive into the Q&A session of our webinar. So if you do have a question for Ben or Robbie, be sure to pop it in the chat now. But before we do, I wanted to tell you very quickly about our installation guide and a new blog, which you are the first to see. Wagners CFT Installation Guide provides contractors and project teams with clear step-by-step instructions for installing Wagners fibre reinforced polymer structures safely, efficiently, and to the required standards. It has been developed to support smooth project delivery and reduce uncertainty during construction. The guide covers all major installation activities, including structural connections, piling, component assembly, and finishing works. Detailed diagrams and practical guidance help installers understand the correct procedures and sequencing required on site. Drawing on lessons learned from projects completed across Australia and internationally, the guide outlines proven, site-tested installation methods that help streamline construction, minimise delays, and support faster project completion while maintaining quality and safety outcomes. Use the QR code on the screen now to read or download the installation guide, and I will also include the link in today's follow-up email. I'm excited to give you a first look at our newest blog, Fewer Crush Blocks, Faster Installs, What Wagners CFT Designers Have Learned. This blog provides an early look at how Wagners CFT designers have refined our FRP connection details based on feedback from contractors and lessons learned from projects delivered across Australia. One of the key improvements is reducing the number of crush blocks used in connections, with these components now only included where they provide genuine structural benefit. This means fewer parts to manage and install on site. The result is faster installation times, simpler construction processes, and improved constructability, while still maintaining the structural performance and durability that Wagners CFT structures are known for. It's a great example of how continuous design improvements can deliver practical benefits for contractors and project owners alike. So if you'd like to be one of the first to read this blog, use the QR code on the screen now, and I will also include the link in today's follow-up email. I'd now like to welcome Wagners CFT General Manager Ryan Leeson, who will be facilitating the Q&A session of the webinar today. Let's have a look at some of those questions, Ryan.
Thank you very much, Georgia, and well done, Benny and Robbie. Maybe before we pile into a couple of the questions, just a first comment, Ben, from you. What's the main piece of feedback you'd give to designers before they do release a set of drawings, be it as IFC or be it to a sort of construction crew to get underway and build? What's the number one sort of thing that we pick up on and you'd love to see addressed at a design stage?
Thanks, Ryan. The simplicity of constructability is definitely the number one thing we need to focus on in design. So how we do it on site in those harsh conditions, environments, tends to be a larger factor. And if design teams tend to can work with us to make those steps easier.
Very good. Okay, so we'll jump into Josabel's question, and thanks for joining us again this month. Maybe this is for you, Ben. Riveted connections are usually between joists and bearers. Are there examples of where rivets are used for other connection types? Maybe you want to touch on the Mackay bridge, the total riveted bridge?
Yeah, riveted truss bridge. So an entire bridge component can have full riveted connections. What we tend to do is the rivet size will jump up from a standard 4.8mm rivet to a 6.4mm oar-lock when a larger capacity is required. So you'll see many bridges we've done in the past years that are full riveted truss bridges.
And what about in obviously a typical boardwalk application? If you talk between the joists and bearers, where else are you utilising rivets? Robbie, do you want to jump in on that one?
Yeah, sure. So there's a very good example on the website at the moment, a job in Western Australia called Luzini Boardwalk. It's a 450-metre boardwalk through a swamp. The designers actually designed the entire boardwalk without a single bolted connection outside of connecting the uprights to a surefoot footing. So there's just a lot of flat plate connection with rivets. But there are some really good pictures and information on that. And if anybody wants to have a look at that design, we can make that design available as well. But yeah, it is the major question with the designers was, will it still be able to take the load? And we actually didn't have to do much engineering ourselves with this. Luckily, the engineers that were involved with DBCA did all of the calculations and came back to us and said, we've done the numbers and it's going to work. So you guys just supply the materials and we'll make it happen.
Fantastic. We'll make sure Georgia includes a bit of detail on that in the follow-up email. Question from Michael Wu at WGA there. How do crush and bushes get installed for continuous members? Ben, this is probably a good one for you.
For continuous members, we would have to pre-drill the components if it's a crush block and install prior to riveting it down or prior to bolting it down. So, like I mentioned in the slides early on, there's a lot of pre-thought that goes into crush block members that are continuous. And bushes are much simpler because once you rivet it down, you can do your mark out and you can just drill as per in situ and then just push a bush through and connect, essentially.
Yep, and I guess maybe if you want to cover off some of the tooling that we have here on site that assists with that world.
Yeah, so the tooling required is our custom drill jigs and drill shafts with the bearings on them. They line everything up for center, but even with the likes of a bush, you don't always need to be center. So you can just use a standard arbor from Bunnings, for instance.
Yeah, and our push machine has a total push length, Ben, of
16 meters, but we can always flip the member and get upwards of about 30 meters as well.
So that's how inserts are pushed here on site. So
yeah.
It's not the same sort of manual on-site method that people use with chocker timber or something. It's all done quite autonomously here, which again is part of the reason why off-site fabrication is always a good win for most projects, which probably leads us into the next question of can you go through this, Ben, some of the opportunities for off-site fabrication that you see? I know you touched on some of the diaphragms and things like that, but maybe if you want to share an example or two of where there was that Mackay project shown in the photos that was concrete footings, dynabolted down, I believe, or casting concrete footings that were fully surveyed, and then the details were provided to us. Just maybe how that timing and off-site fabrication can work, just depending on the site project.
Yeah, right. Yeah, so in the instance of that one, I mean, we at the sheds in Toowoomba, Wellcamp, we can definitely do more work and pre-drill posts, put the brackets into the post if you wanted, bolt it all in, and essentially just land them down on either cast-in bars or just drill it into the concrete on site for the likes of that Mackay job. But in general, we can often pre-drill as many members as you would like, depending on tolerances required on site, and vice versa. If anything needs to be pre-riveted, we can take a lot of the load of the amount of rivets off your on-site teams.
Okay. For truss bridges, like the cover photo, what's used for the diagonal members to top-bottom chord connections?
It's both top chords, bottom chords. All the members you'd see in a truss bridge like that are all crush blocked. Depending on load requirements, sometimes also a glued connection. In those cases, we would be using the mechanical aid, as Ryan mentioned. We would pre-drill everything, pre-insert everything, and essentially just put it together. We can control the tolerances as we're building on a flat level ground at Wellcamp, as opposed to when you're on site and things can go wrong.
And Robbie, that's a bit of a segue for you. Do you just want to cover off for us and sort of prefabrication or modular construction are all very topical things in all sorts of construction industries at the moment. Where's the benefit, and why do you think there's such an opportunity for contractors to be leaning on off-site fabrication for their projects?
Well, there's probably a number of reasons. Some of them based as simple as areas can be high trafficked and high profile areas. And sometimes you want to get in and out in a day or two and finish a job without having to close down a walkway. I remember a story one of our BDMs from a few years ago used to regularly say that they did a bridge in Queensland where kids would go to school crossing an old timber bridge, and on their way home from school, they were crossing a brand new FRP bridge. So time on site is a big one, but also some other reasons, particularly with highly environmentally sensitive sites, are making sure that they are reducing the amount of dust and things like that can go into the environment. But yeah, so getting a job done really quickly is probably the main one. Not having to close down high traffic areas, environmental factors, but also if you've got a small team and you want to install a large project, it's a lot easier to just unload a fully fabricated bridge off a truck than it is to fabricate that bridge, have a crane on site most of the day, moving girders into place and bolting it all together. So yeah, there's efficiency is really what you're looking for, but I mean, and to save some costs on the project as well.
Yeah, it's one of the things I was going to say. The weather variability, as Ben knows, southern New South Wales at the moment, a bit variable with the weather and unpredictable. If you can complete things inside a shed in controlled conditions with mechanical aids, is always opportunity for improvement. So there is a blog on our website around building smarter, faster, and more cost-effective modular infrastructure. So that's something if people are interested in. The next question from Josabel sort of delves a little bit into next month's webinar, which is around the drafting guide and the real ins and outs of the connection details. Ben, I'm not sure if you can cover it off the top of your head. I certainly can't. There's only limited riveted connection capacities available in our design guide. For the Lucini boardwalk in WA, did they use the Wagners rivet capacities or did they use their own numbers? Robbie, maybe you know that? Maybe it's something we have to take on notice. I'm putting you both on the spot here.
I would assume it would probably be a combination of both. There was a little bit of backwards and forwards with the designers prior to the tender going out, where the designers reached out direct to our technical leads with some queries about rivets. So I know that if they didn't do the numbers themselves and it wasn't in our available information, I feel like our technical guys went and did those numbers for them and came back with a result, which is something we do with a lot of externally designed projects. Quite often we're actually assisting the designer through that process and answering any questions that they don't already have.
Yeah, okay. Well, we'll make sure we take that on notice. I do know from a toolbox myself that we were doing some riveted connections 3-ish months ago and a whole heap of testing on it. So maybe that was to cover that out. That sort of, I guess, demonstrates that if someone has something out of the ordinary, Josabel, if it's you and you've got a different riveted length or connection detail you want us to look at, we're more than happy if we don't have the data already to complete the testing and provide that for you. It's all around sort of building that flexibility in design. Robbie, I guess 2,000 structures, and you've been around for a big part of those. What's the sort of feedback Ben touched on before, the feedback that he would give to a designer before they put a design out in the field? What's some of the feedback that you've got or biggest lessons learned? Some of the people listening today will be designers involved in that space that you've heard from contractors in a positive light to say, geez, it's great you've been able to adapt to this or adapt that and it's made our life easier. What's some of those things as our designs have evolved?
Yeah, I guess the advent of the crushed tube has significantly increased or decreased installation time and costs. So I'm getting a lot of really good feedback from installers who are saying that using the crushed tubes has made their job a hell of a lot easier. But as some of the simple things which often can be addressed in a very short Teams meeting with a project delivery team and the contractor, simple things like sanding down crush blocks before you put them into place. I've walked onto a site and had a contractor shake his head at me and say, "Oh, mate, these are a nightmare." And I said, but don't you remember that conversation we had last week about sanding them down before you put them in? And he goes, oh, I've completely forgotten that. And for the second half of the project, I didn't have an issue with him. It's very easy to cover across a bunch of very simple tricks of the trade to increase your speed of installation, and going in blind and just assuming that you're going to do it the way you did it with steel or timber can often leave you in a little bit of a lurch, because FRP is quite simple to install. There's no specialized installation. It is literally just different cutting material, different cutting blades, and different hole drilling saws. And outside of that, it all slides together like a Meccano set. So a little bit of early preparation is always key.
Very good. That's a lead in for Ben. If a contractor's, what's the biggest misconception for contractors of working with FRP if they haven't worked with it before, maybe particularly in the cutting and drilling of the members?
The biggest thing that I guess can go wrong and scares a lot of people is that things come down with no extra green length on them. And if they are, they tend to be pre-drilled or set to a length. If you make a mistake with that member, you can't be replaced. However, it can be quite easily replaced. We just need to know at the beginning of the projects, I guess, that there's a risk of tolerance not being enough, and we can budget extra members in there, or we can discuss whether or not we put green on there, or a better design potentially to help reduce the tolerance required.
What would be your recommendation from your experience? Would you allow green? Let's focus on a boardwalk because that's the most common hacked job. Would you recommend that people take green on each stick, and also what sort of additional members, or if we're doing 200 bearers, I think the example was in the previous one, how many additional bearers would you recommend that someone orders, or would you recommend they just order standard 12.5 meter sticks that they can have up their sleeve to use in various applications? How would you run that if you are on site and running it at the moment? How did you run it for your job?
I would recommend that you always have extra piles on hand for a boardwalk, like just a standard boardwalk, because if something does go wrong, it moves, it changes its location because of driving, then you can always put an extra pile in. We can always have shorter spans rather than longer spans. Bearers, I would always recommend green. Joist, I would always recommend having green, because those are the things where if you have the extra length to play with, you're always going to be far better off on site, rather than being short or being to exactly what you thought you were going to be and having to make a phone call and lose a week's worth of time trying to wait for material, or even just get an approval to be able to get the extra length over the line. So just getting all those discussions in nice and early with our design team or an engineering team will save you so much time on site.
Understood. Robbie, at what stage should designers and/or contractors, I guess, who are the key ones that stand to benefit, what stage should they be talking to Wagners around opportunities for off-site fabrication and time save?
Oh, that would always be at quoting time. So generally, once you've been awarded a tender, if you're about to place an order, yes. But if it's 3 weeks before you're on site, generally that's a pretty tall order for us to be able to find some labor time to actually do prefabrication. So the earlier the better to have the conversation, because you may even find out that prefabrication may not be beneficial for the particular project you're in. So an early conversation is always best. It can be quite easily found out whether it's going to be beneficial by some backwards and forwards between yourself and our project delivery team. And then we can put some things in place and say, right, this is where we might be able to find you some savings and some time savings. So we'll give you a cost for us to prefabricate this portion of your project.
Fantastic. Well, that closes us out on the questions today. Ben, did you have any final remarks as someone that's pulled your hair out many a times on a project, equally due to our own designs as other people's designs? So we have to acknowledge that we too have learned and developed based on the feedback of our internal team and our contractors who work with every day. Did you have any final comments to close out?
Just always make a phone call back to your project delivery team at Wagners. We're here to help. Like everyone within our internal team is able to help. There's no real problem that is going to pull up a project and make it completely stop and be unfinished. So have that phone call and be willing just to work in with our engineering team. We'll always try and come up with the best scenario for your on-site construction if something needs to be fixed.
And Robbie, 15 odd years of playing in this space. Any final comments from you, and then we'll hand back to Georgia when Robbie's finished.
Probably not a huge. I think we've covered most of it today. But I just think it's important to have open dialogue between contractor and supplier at an early stage. And then again, the resources that we have available in our design guide and our drafting guide, we've put a lot of time and effort into compiling these documents. And the reason that we have these particular connections for these particular parts of our structures, there are reasons for it, because we've found that these are the most efficient or best performing capacity connections. So if you're on the design side of things, please refer to our drafting guide when you are designing, because that will quite often remove a lot of the potential issues down the track, because we've probably already looked at all the problems that could happen and have made a decision as to why we use those connections. So use the available resources as well as using the available expertise that we have at Wagners would be my main takeaway.
Fantastic. And just a shout out, Robbie has dialed in from SA today. I know he's got a conference over the next couple of days, and Ben is in Merimbula on the south coast of New South Wales on an install project at the moment. So we do appreciate both of you dialing in and taking the time to be with us today. Georgia, over to you.
That concludes our presentation today. A big thank you to Robbie and Ben for your involvement, and thank you to Ryan for facilitating the Q&A session. If you'd like to share your thoughts on today's webinar, please feel free to complete the feedback form by using the QR code on the screen now, or the URL that I have just popped in the chat. Or perhaps you'd like to be a guest speaker. If that's the case, fill out the feedback form and let me know. You could also reach out to me on LinkedIn, send me an email, or give me a call. However you want to contact me, I would love to hear from you. Coming up in July, we'll be wrapping up this 3-part connections series by exploring how Wagners CFT is improving fibre reinforced polymer infrastructure delivery through practical drafting standards that enhance clarity, reduce errors, and support efficient construction outcomes, with guest speaker, Wagners CFT Design Manager, Jason Ziske. So if you're interested in attending this webinar, use the QR code on the screen now to register for your free online seat or to receive a recorded copy of the webinar. Link is also going in the chat now and will be included in our follow-up email today. That concludes our webinar for today. Thank you very much for coming. We're going to go out on the video from the beginning of the webinar. Enjoy, and we look forward to seeing you next time.